Hello and welcome to another episode of the Blockchain Interest Group podcast with your host Nikhil. BIG is a consortium of individuals who are interested in the blockchain and distributed ledger technologies. You can learn more about us on our website big-org.com or follow us on our social media using the links in the description given below. Today we have a very special guest with us on the show, Sandra Becker, joining us all the way from Europe. Sandra is an economist with more than 10 years of experience in designing statistical models within market, social, and trend research. Sandra is the co-founder of the Ethereum Madrid blockchain community and teaches the concepts behind Bitcoin and Ethereum for various educational programs. She is currently focusing on research around cryptoeconomics. So the topic for today essentially is going to be cryptoeconomics. It is a new research field that has come out of some of the unique challenges and characteristics of cryptocurrencies. And it plays an important role in all aspects of cryptocurrency design and implementation. So, Sandra, why do you think everybody is talking about cryptoeconomics now?
Yes, so actually, Bitcoin 10 years ago opened like a box of Pandora because it showed us a totally new way of people to interact, and in this particular application of using money in a decentralized way. But we know that today actually we have several kinds of blockchains. We know Ethereum, we know all the possible dApps we can create, DAOs. So we have so many different ways now of creating small decentralized worlds. And all of these worlds, they need their own mechanisms. So they need their own rules. And cryptoeconomics is like a research field, which tries to, or which actually is the basement for creating different ways of mechanism, different ways of solving in a more personalized way different kind of problems. Because in blockchains we have most of the time the problem, how can we create in a secure way consensus? But in different token designs we have other desired outcomes. So cryptoeconomics is like a general word for defining this the rules that lay under this new decentralized world we are creating. And on the other hand, I also believe that we have this hype around ICOs, and we know that most of the people are really focusing on the ideas, the white papers, the team. So we have like an alpha episode of the new token world. But we know that to implement all these new great ideas, we have to create also a grounded mechanism, and this is again then the cryptoeconomics, where we can use it and actually see if these great ideas will work in reality. So true. I believe that the next step will be focusing not only on the idea, but also what designs do these ICOs have, and did they make experiments, did they create like small tests already? So it's like the better version of the ICOs will include cryptoeconomics, I believe.
Yeah. So to paraphrase, I think, so like you very correctly pointed out, we are in a very early stage and there is a lot of hype. People are looking at ICOs from the perspective of the idea. But you really need to understand that an ICO or even a cryptocurrency is more than just the software. It is also it is a community of users behind it, and the behavior of the users is what actually drives the value of the ICO or the cryptocurrency, and that's what cryptoeconomics is looking at, right? So Sandra, could you talk a little bit more? So what is cryptoeconomics exactly, right? In detail, what is it exactly?
Yeah. So actually, cryptoeconomics is quite old already, because Vlad Zamir, a researcher from the Ethereum Foundation, was already speaking about this field in 2015. But at this time, he defined it as a discipline for studying protocols, because the main focus in 2015, obviously, was blockchains. And for Ethereum, in particular, so proof of stake, so create a new consensus algorithm. And cryptoeconomics, as it says, the word is actually a combination of two different worlds. So on the one hand, we have crypto, which always people that are in the crypto space knows that crypto always refers to cryptography. So cryptography is a toolbox we can use. So, and on the other hand, we have the word economics. And economics is a social science that studies the production of services with a main focus on human behavior. So in regarding the blockchain space, we have different kinds of rewards and penalties we can use to motivate people to interact in a certain way. So on the one hand, we have rewards, which can be tokens or any kind of value you give to the people when they behaved in this way. So you give them something positive. That's right. Obviously, it's called reward. But you also can give them privileges. So in Bitcoin, for example, we know that miners have the privilege of deciding on the order of transactions. And on the other hand, penalties can also be used to manipulate or change the behavior of the humans. So you take this away, you take the tokens away, or you take the privileges away. And by just designing the rules this way, people might not do certain things because they want to keep their tokens and their privileges. So therefore, cryptoeconomics is this combination of cryptography, like a toolbox, and on the other hand, we have economics, which focus on incentives to move human behavior in the future in a desired direction.
Oh, great. So actually, just wanted to comment on that. Vitalik compared the challenges of this particular thing to those of an AI and summarize it as, how can we regulate a very complex and very smart system with the unpredictable emergent properties using a very simple and dumb system whose properties are kind of fixed.
Exactly.
Right.
Exactly.
So so that's a great definition, or rather, that's a great introduction into what is cryptoeconomics exactly.
In AI, we have the same problem as in cryptoeconomics. Humans are really complex in making their decisions. And in AI, we try to copy this human behavior and program our computers that way. And in cryptoeconomics, we do something similar. We create designs, so mechanisms, designs that are surrounding the humans so that the humans will do something we wanted. So it's a little bit like playing God. So you create rules, and because you design the rules in this way, the humans will behave in a certain way. And in the end, the outcome is what you wanted, a social desirable outcome.
Very true, very true. So it seems like a very complex topic, and has multiple fields of knowledge and even other sciences like economics. So could you elaborate about that?
Yes. Yeah, that's totally true. I mean, the world is really complex, and as soon as we want to decentralize the world and make that everything works autonomously, we need to have really complex systems, and cryptoeconomics is the field to design these systems. So it includes really like 4 different research fields on its own. On the one hand, we have cryptography, as I said, and cryptography offers us a huge toolbox, which might actually extend in the future even, but we already have, like, for example, digital signatures we can use to prove that I'm the owner of something, the owner of an address, the owner of a document. So I can use this tool to show something which gives evidence of a certain characteristic which no one can ever change. Cryptography can also, we know hashing. We know in Bitcoin how much hashing is used to show, for example, the order of the blocks. And we know that just by using these hashing systems in proof of work, we have already defined the order. Or in Merkle trees, hashing is used to show that something is included in something. So cryptography is really like a discipline in cryptoeconomics that gives us a toolbox to show and give evidence of certain things that no one can deny. So it's really certain. And then we have game theory. So game theory is a research field which focuses on human decision making, but in a way that you are, so you enter a game, and the game is most of the time that you can just decide between two behaviors. So one is to cooperate and one is to cheat. And based on the incentives, which I explained before, like rewards and penalties, you will behave in a different way. And so, for example, we know that in the First World War, there was a moment when the French and the Germans, they were in the situation in the winter, we could just both attack each other, but then we would both die. Or we would both not attack each other, then we would both survive. So this is actually the most desired outcome. But the problem is, if I don't attack, but the other attack, I will lose everything. So you are in this prisoner dilemma sometimes, that you don't know how to behave, because the incentives are just put in a way that taking into account how others behave, you are stuck. You won't move. No. And game theory has far more than the Nash equilibrium and the prisoner's dilemma, has far more games already designed where we can investigate how people behave under certain circumstances. So these are two fields which are really important: cryptography, toolbox, game theory, experimenting with decision making of humans. But this is no cryptoeconomics so far. So cryptoeconomics is now actually more defined by mechanism design. And this means that now, as we know all the tools we have on the cryptography side, and we know from game theory how people behave, we now create like a rule set. And in blockchain, we know this as protocols. So we write down all the different conditions and say, if someone has proven cryptographically this, then, and he behaves like that, he will get this incentive. So we write down the rules, because with all this protocol, in the end, we want to achieve one goal. And this goal is not an individual goal, but a goal for the whole application itself. So in blockchains, the goal of every consensus algorithm is to have security, that we can find a consensus in a decentralized way which is secure and no one can attack it. This is the goal. But you know that each individual will only see his own or her own benefit. So therefore you need to understand game theory to really design this incentive structure. And then the last element is network economics. It's not so much an element of cryptoeconomics itself. It's more the world in which all these new application blockchains live are networks, and networks have a different dynamic. So really important effect is the network effect. We know that the bigger the network gets, the more value it has.
Yeah, so Sandra, as you were saying, mechanism design is an interesting area, because as far as I can tell, what we are doing is we are trying to define the rules, shape the behavior of the users, right? Whereas in classical game theory, what we are looking at is we are looking at the behavior of the users and then trying to derive the rules of the game. Interesting take on these things.
Yes.
What do you think?
Yes, it's actually some people also call it like inverse game theory, because in game theory the rules are set, so the incentives are set, and everything is, the situation is clear, the scene is clear. what we are analyzing is how the humans now behave. What strategy will they play, and what is the most successful strategy to play? In mechanism design, it's reverse. No, so we now will have like open our rules. We can change the incentive structure. We can change the conditions, but what is fixed is our social outcome. So, for example, let's say the case of an auction. So, in an auction, we have a product, and we want to distribute or to give this product to the person which has the highest utility for this product. But if we do an auction like the most common one, where we say those that have the highest bid will get the product, the problem is that every participant of this auction will just put the highest price they can pay, and this includes already all their costs. So if they then finally win the auction, they will come out with a zero benefit, because they wanted to win the auction. They let's say they bet with everything they have, and therefore even if they get the product, they have nothing actually won, because they put like everything on stake. So a different way to design this would be like it's another concept in which you say you win the auction if you bet the highest, but you actually have to pay the second highest bid. So in this way, you still incentivize people to try to win the auction, so to bid highly. But at the same time, if I bid really highly, I have to pay it in the end. No, I don't know what the others will say. But I know that in any case, what I will say, I have to pay less. So I will always win. So I still want to make it high because I want to win. But in the end, I don't have to pay everything. So we can see that two different designs will cause a totally different outcome. So the outcome is it will get to the person who is capable to pay the most, but this person will still have a benefit from it. Yeah,
True.
So this is just an example to show how mechanism design can work and can be used in different situations.
Sure. So elaborate a little bit about network economics.
Exactly. So all this blockchains and all the decentralized applications, they live obviously in networks. And networks have their own dynamics. And the most important or the most famous one is the network effect, which says that the higher the network gets, the better the value for each participant. No? If we use social media, we know the more people are in social media in this network, the more valuable it is for us. With Bitcoin, the more people use Bitcoin, the higher the demand for Bitcoin. So the price of the Bitcoin I use, or Ether or whatever, will just go up. But on the other hand, so then we could argue the best would be just to have one big currency, one big cryptocurrency, because this would have the highest network effect. But this doesn't take into account that the preferences for the persons, and this is in mechanism design included, are different. So maybe like we know the different forks in Bitcoin. So maybe I'm against ASIC mining. So from my personal view, I would prefer that there is a fork in Bitcoin that provides mining without ASICs. So even though from a global perspective, that's not the highest network effect, from an individual perspective, this gives me more utility. So therefore, we have to understand that in certain moments, actually, a fork will lead to a better outcome because it will provide a new solution for a new community to grow. And this is all the dynamics in networks which we have to take into account when we create these mechanism designs. Yes, this topic, even though it's really recent, we can see already that on a global level, which is really nice, so really in a decentralized way, on different continents of the world, so in Australia, in Singapore and Austria, research groups are built up that start to focus on this new field, because there's so much more to investigate. It just came out, really. It's like a baby, so we need to create new papers, we need to investigate, we need to experiment. And also the Ethereum Foundation has, obviously, proof of stake is an important topic, really important topic. So also there, cryptoeconomics is like a separate research field with a separate research group working on this. So there we see the importance of this new topic.
Awesome. So, Sandra, how do cryptoeconomics actually help blockchains become better, get safer?
Mm-hmm. Yeah, so we have at the moment cryptoeconomics is applied to different layers in the crypto world, and one layer is obviously the consensus layer. So how can we achieve consensus in a decentralized and safe way? We know proof of work. We've seen it for a long time applied in Bitcoin. And we've seen that there are also some problems. We know about the energy-based. We know about the pooling, the centralization problem maybe there. And we also know about attacks. So a way to be sure that a blockchain, a public blockchain, is safe is by checking on attacks. And with attacks, I'm referring to game theory attacks. So what is an example for a game theory attack? So to reach consensus, to reach consensus, we can use sometimes something which is called a challenge point. So let's say I ask several people who won the election in US last year. But I obviously don't know the truth, so I can't check if the people tell me the truth. And I can't even force people to tell me the truth, because I can never be sure if it's the truth. But I can create a mechanism, so I can create rules. And with these rules, I can get to the truth. So this rule could be, I say, if you say what the majority says, then you get a reward. So this is the incentive. So now everyone is thinking, what does the majority will say? And the majority in this game is the truth. The truth in this game is a challenge point. So it's easy to agree on truth than on a lie. So therefore, everyone will just say Trump, because they know it's the truth and they want the reward. So they reach consensus, and I can be sure I know the truth. But this mechanism can be attacked by a bribing attacker model. So how does this work? Obviously, what a person could do could just bribe all the people and say, if you say now Hillary, I will pay you. But this is really expensive. So, and it's still not sure. So you might pay them, and in the end, they say something else. So it's actually not a really secure attack, and it's really expensive. Another way to do it is that I do another condition in this design. So I say, as you know, when you say what the majority says, you get paid by Sandra. But now I make another condition. So if you say Hillary, but everyone else is saying Trump, so you don't say what the majority says, then I pay you. So now we have, and this is now game theory, we have the people thinking, what should I do? If I say Trump and everyone says Trump, Sandra will pay me. If I say Hillary and everyone says Hillary, Sandra will pay me. But if I say Trump and everyone says Hillary, I won't get paid. But if I say Hillary and everyone says Trump, this attacker said to me he will pay me. So what we realize is the player, they will win always if they say Hillary. So therefore everyone will say Hillary. And because everyone says Hillary, in the end, the attacker doesn't have to pay anything. So that's a really good example of a game theory attack, because it uses really this incentive mechanism. So as we have seen, it was an additional condition put in the design. And with this additional condition, the attacker achieved what he wanted, that I think Hillary won the election. And the interesting part here is he or she doesn't have to pay anything. But so now the question is, why is this not happening all the time then? Yeah, well, because these attacks, they might fail for different reasons. So even though we think people always behave rational, we actually know that in the truth, this is not the case. So there are sometimes people that say, I will say the truth, whatever it takes. Or it could be that some people just don't understand the rules. So they just don't get it. There could be technical problems. There could be so many problems, mistakes, that the attack in the end won't work. And if this is the case, so going back to the bribing attacker model, so if in the end the majority is not reacting as the attacker wanted, so the majority will say Trump, but a few say Hillary, the attacker actually has to pay a lot of money. And this is called the budget of the attack. So the budget of the attack can be sometimes really, really high. And only because of this high budget, this high risk to pay, attacks often are not taking place. But this is just one example of an attack. We know already quite a lot of kind of attacks. We know that one of the most dangerous attack in proof of work, and also in a way in proof of stake, is the 51% attack, where one node or pool or whatever has more than the majority of the hashing power, and therefore is capable to create a secret chain, not even a secret chain, it's just capable to create its own chain. And because he statistically will always win the race, he can decide on the transactions. But what is the problem of this attack? This attack obviously seems to be really interesting because you can control the network. But first of all, we have to look at the investment. So getting 51% of hashing power is a lot. Is speaking about Bitcoin is a huge investment because the network is really big already. So you have to have a lot of hashing power, a lot of computational power. Then, on the other hand, your attack can actually lead to a result that people will be aware of the attack, and then different things can happen. The community could decide just to fork away, to create a new Bitcoin, so your hashing power is for nothing, or the people just start selling their Bitcoin, so the price will go down. And what you actually achieve with your attack is nothing worth anymore. And therefore, one rule in all these consensus protocols is that we create or we design mechanisms where it's more profitable for the participants to actually work with the system than against the system. So in this case, if we take the 51% attack, we've seen all the costs, we've seen all the investment, and we've seen all the risk. And now, imagining someone has 51% of the hashing power and would just do mining, this person would just, or this node, would just gain with every block in the Bitcoin, for example, 12.5 Bitcoins. So it would be far more profitable to go with the rules than against the rules. And this is a really good design, which is a secure design, because it has, based on game theory, it has created rules that make people play by the rules, because they win the most if they play by the rules rather than they attack the rules.
Yeah, true. And in fact, actually, I just want to quickly point out another aspect to it, that, see, one of the things you'll notice over here is that a lot of it a lot of these attacks, basically one major factor in them is the transparency of the network, right? A lot of these things you cannot do, like a 51% attack, for example. Realistically, if in Bitcoin anybody sees somebody getting 51%, right? The next thing that is going to happen is the value of Bitcoin is going to go down, because people immediately start panicking about that particular aspect of it.
Exactly.
And because of that very fact itself, miners would consciously try to avoid becoming 51% majority.
This actually happened.
So and they cannot hide the fact that they've got a 51% majority, say, right? No. In fact, it can be taken as a threat to the system at that point itself. So this is another interesting thing I see, which is fundamentally different, in my opinion, from the way most things work nowadays, right? Even today, if you look at big economic systems or big government, everything is behind closed doors. It's kind of opaque. We don't really get to know about it until it is actually it is actually implemented. But since it is so transparent, the game theory or the mechanism design rules, they're out there in the public. Everybody knows these things, and because everybody knows these things, there's less resistance, or the despite the fact that everybody knows them and it is working, it still works, is a testament to the fact that these are really good, well designed system.
Exactly. Right? I mean, we can just see it also in the proof of work protocol. We all know that the miners, when they create their blocks, the first transaction is a transaction to themselves, and the protocol says exactly what they can put there. So why no miner would ever put 14 or 20? Because this, you know that if you do this, it's most probable that your block will not be accepted as valid, because the network will play by the rules. So you are actually forced to behave good by the mechanism. And this is unimaginable in our world today, where we have policy, where we actually you react afterwards. Afterwards, when someone did something wrong, you penalize them. And in this mechanism, you have to set the rules in a way that it's not profitable for the people to cheat. So the most profitable way to act is play by the rules.
Right. So moving on, Sandra, so another question that we wanted to talk about is that what does token design actually stand for? So obviously nowadays with ICOs and other new cryptocurrencies coming up every day or every other week, we have a lot of tokens coming into the market. And one of the things that we have seen with what we have talked about earlier, the way these tokens are designed is important. So, and how is this token design and cryptoeconomics related to each other? Could you elaborate a little on that?
Yeah, exactly. So we create like new applications, and the central point of all these new, with central point, I mean the central point of attention of all these new applications is the token itself, no? And behind this token, there stands some rules. So how can you get the token? How can you lose the token? And how is the token distributed? These are all rules. And this is actually design of this token application. It's quite interesting because at the moment, as the focus is so much on the ICOs, we see actually a lot of mechanism design applied to token sale. So we know in the beginning there was quite a simple way of sale the tokens in an ICO. Now we know that more and more of these startups try to create new ideas about how they would sell the tokens in the ICO to make it more fair. There is an example from the Gnosis ICO where they used the reverse Dutch auction. And I don't want to go into detail here, but the interesting thing about this is that they put quite a lot of effort in designing a new way of selling the tokens, so that actually people that would wait for the price to come down to the price they are willing to pay, that they get actually a higher benefit, an individual benefit. But in the end, what happened is, because in this ICO world, or at least in the past, people were so irrational. They wanted to have the token as soon as they can, because they were so afraid of losing the opportunity to join the game. People actually didn't even care about the design of the mechanism. So people behaved irrational. They just bought in the first moment, even though it was far more expensive for them that they were willing to pay. But they just wanted to join the ICO from Gnosis. And this is also based on information, because there was quite a lot of information about that the future price of this particular token will be high. So people were not focusing on the token sale mechanism, they were just focusing on getting the token, because they wanted to have it in the future. And there we can see that sometimes, even if we create really good designs, if we don't take into account actually the whole scope of our world, then these designs can just fail, because humans behave irrational, because they got information and they think this information is more important than the design itself. There is a really interesting article written by Vitalik Buterin about different token sale mechanisms. And then the other thing is, obviously, once we sold maybe in an ICO the tokens, we also have to create rules of how we use this token in our application. And a really, really good example of seeing this in practice is the way how stablecoins work. Because stablecoins, like for example the MakerDAO project, they use all these mechanisms to create a coin, which is the social good here. So the final goal of the mechanism is to create a coin which is stable. So in this case, which is stable to the SDR, to a basket of all the fiat currencies in the world. And then they set the different rules, which are really complex. It's a really complex design, but it has to be that complex because our world is so complex. And by all these rules, they achieve this result. And for me personally, I also found it quite interesting that, knowing how our current financial system works, in a stablecoin system, it's actually those that make a bad decisions. So if you make a bad decision and you include a currency which is not stable in your stablecoin design, you have to pay for it. You actually have to act and pay for it. So you lose money. So if you make a bad decision, you have to take the responsibility. And we know, I would say, it's quite different in the current financial system. So that's really an interesting application. And I assume we will see far more in the future.
Right. So that's a great point on stable coins. I really didn't think of it that way. We should actually at some point go a little further into it. But let's get back into our topic. One other question I actually had was with regard to some of the layers that's being put on top of the BTC and Ethereum networks. So one of the main problems, or one of the main complaints against the Bitcoin network and Ethereum and any kind of proof of work kind of network is the fact that it is slow, right? Mm-hmm. And it is not really scalable. You don't really, it's expensive, and it's hard to actually imagine that this particular system would be able to handle the world's financial transactions. Mm-hmm. So there's been a focus of late on what are called payment or state channels, right? Mm-hmm. And these basically are layers on top of the underlying Bitcoin infrastructure or the Ethereum infrastructure. And they basically profess, or they claim to make it much more scalable or much more fast. Now, the Raiden network, for example, represents such a network of state channels. Can you explain from a cryptoeconomic perspective, right, how the Raiden network actually is implemented?
Mm-hmm. Yeah, that's actually a really, really good application because it's quite simple, but it uses exactly the idea behind cryptoeconomics. So how does this work? It works like, we know that the problem is when I do transactions on the blockchain, it's slow, it's fast, it's slow and it's expensive, and it might be even not scalable. So I can't even get maybe a confirmation. So the desire then here is to create a new way, as you explained, of transferring money, but not going through blockchain. But then we have the problem, as we all know, it's not secure. Because if I do a transaction with someone, we can just do double spend again. So we are back to our problems from before Bitcoin. So therefore, the idea behind state channels is we do a transaction which is peer-to-peer. So there is no blockchain between us, but we have locked up the actual, like a debit, yes, like a debit. We have locked up our money on the blockchain in a smart contract. So if I, for example, want to transfer money with Unicle, for example, I would create a smart contract and lock up 100 Ether, and then I will open up this state channel with you. And every time I transfer Ether to you, I will create a balance proof, which is some structure of digital signature. So I cryptographically prove that I've done this transaction, and just do it whenever I want. So I can do 1,000 or 1,000,000 transactions, really small ones, to you during a whole year or even 10 years, as long as we want to open this state channel, because it's all backed up by my smart contract. And the way it works is game theory, is incentive. Obviously, I could behave wrongly, but now I know I will just lose all my locked up Ether. So I'm incentivized by the smart contract actually to behave well, because otherwise I will lose it. And you, as soon as you want to get your money, you can just close the state channel. And in the moment you close the state channel, you use my balance proof. So you got from me the balance proof transactions, you show them, and you get paid out. And I get paid out the rest that is still in my account, if I have something left. So this is the basic idea, which uses, as we've seen, cryptography to prove certain things, and it uses incentives, which are locked up in the blockchain, that we behave correctly, because if we behave badly, we lose our money. But then the most interesting part actually is the network itself. So this is just one state channel, but obviously we can't open up a state channel with everyone, because this would mean we have to lock up so many Ether or so many tokens. Also, everyone doing a state channel with everyone would be really inefficient. So therefore, there is the idea, why not using the network? I want to transfer money to KK, but I don't have a direct state channel with KK. But I have a state channel with you, Nickel, and you have one with KK. So that now I can use a new mechanism. It's actually a mechanism written down in rules how it works. So what I do is I use cryptography, and in this time I use hash-locked transactions. Hash-locked transactions are transactions that are locked, so you can't actually use them at the moment, change them, because you need first to know the secret. So you need to have the key to open them. So I will transfer this hash-locked transaction to you, and you forward it to KK. And now KK sees this, and obviously he wants the money. So what he does is he requests now from me the key, the secret. And I, in this moment, realize, KK got the transaction, because only then he would have requested it. So I know the root is there through the network. So now I will give him the secret key, and he can now open up the transaction by forwarding this key to you, because he needs to do this because he needs to have the root confirmed. And you, as the middle point of us, you will do this because you also get an incentive, because you actually get a small fee. By providing your state channel connection, you get a small fee. So KK will transfer this key to you, and you transfer it to me, and then you can actually open up these transactions. So then you have actually a balance proof transfer for me, which goes through the root, and you got the fee, and KK got the final money. So this is the way, how they can use the cryptography and the incentive structure to create a whole network which doesn't need to use the blockchain to make transaction. But we still need the blockchain. That's really important. If there weren't the Ethereum blockchain, we couldn't have the Raiden network. But everything in the Raiden network is not using the blockchain.
True. So it's like the Ethereum network essentially is the underlying layer that allows this to happen, that the infrastructure happens.
Yeah.
So
exactly.
it's obvious the cryptoeconomics is a very useful concept and a very useful field in this whole cryptoeconomic cryptocurrency space. How do you see the future of the decentralized world and the application of cryptoeconomics within the
I think we will have a boom around this field, because, as I said, it's the basement for everything. So at the moment, we are a little bit like in a Wild West, especially what ICOs and applications refers to. So we don't know anything. We don't know how these things work. In blockchain, quite a lot of people are already really familiar how things are working. But I would say application is still a really, really green field. And cryptoeconomics can help us to create all these different, as we said, and as we've seen in all these examples, to solve the problem. So I think we will see a lot of more research groups, a lot of more experiments. But at the same time, it's also a little bit, I don't know how to say it. Dangerous is a really hard word, but we should be careful also, because once we've set a mechanism and we let it out, let's say, and an autonomous decentralized network will use this mechanism, it's difficult to make changes. We see this in Bitcoin. So, or as Nick Sabo said it, in the end, we are speculating on the people's future mental states. So we don't know if in the future, in the far future, the same incentives will play the role as they play a role now. And if we just set up the rules in stone nearly, it might be difficult to predict how this will all interact in the future. So this
absolutely
should be something we should be concerned about, and take this into account and do more research there, I assume. A little bit like AI itself.
If I could interject there. So actually, you bring up a very good point, Sandra. One main thing I think we as a community in the cryptocurrency space need to learn is to bring in governance. How can we evolve our system in a decentralized manner? Because if you look at it currently, even from a security perspective, right, a lot of these cryptocurrencies are very centralized when it comes to the software and the software updates, the maintenance of the software, and there needs to be appropriate mechanisms built in. I'm sure cryptoeconomics will play a big role in that as well. In terms of defining how we can actually have this software or this particular system so on in a decentralized manner without a benevolent dictator or a single person or group of people directing.
Yes. Yeah, it's also totally as you say. It's like the governance structure is so important, and actually when we look at it, it's a little bit like also copying what we have in our world now. I mean, in a lot of countries we have democracy, and we know how many rules, how many laws are written down to make this democracy more or less work, and we know how many rules are set. If this happens, so then this will happen. So we have actually, we have this already. We only need to now apply this to this new decentralized world we are creating. And that's why I also call cryptoeconomics is like the design of this new decentralized world we want to create. And I think it's not only this, also we will see maybe splits within cryptoeconomics, which are actually already the case. So there is institutional cryptoeconomics. This is more referring to the ICO's structure and the tokens itself. And then we have also something called macro cryptoeconomics. And there we have all the interactions between Ethereum blockchain, when they change their difficulty target, how will this affect on the Raider network or no? So you have interactions on a macro level, which you also actually have to take into account in your mechanisms you are designing. As we've seen also in the Gnosis token sale. So take into account what are the informations, what is the reputation maybe of Gnosis. So if the reputation is so good, people just will buy the token in any case. So yeah, it's more looking at the global level of cryptoeconomics. So it will be really interesting and exciting, I think, the next years. And I assume we will see a lot of new projects and research groups around this topic coming up with new ideas.
Absolutely. I agree, Sandra, and looking forward to hearing more and learning more from you about this particular interesting field. All right, folks, that concludes our podcast. We hope this episode on cryptoeconomics was useful to you. Please leave us your comments in the comment section below. Follow us on our social media. We are on Facebook, Twitter, and LinkedIn. And we also have a very active Telegram group. The links for all our handles are in the description below. Thanks again for joining. See you next time.